Hello, this is Mrs. Bobby, and we're going to start some quick geometry notes to prep you for whatever piece of geometry you need. This is a segment. See that it has two endpoints? You can actually have a distance on a segment. This is a line. A line has arrow tips on both ends because it cannot have a distance because it goes both directions for forever. This is an angle. It is comprised of two rays. So like here's a vertex, there's a ray together. They meet at the same vertex forming an angle of some kind. This is considered a perpendicular. A perpendicular is a horizontal and a vertical line of some kind forming a 90-degree angle known as perpendicular. These two are considered parallel lines. They are consisting of two lines, like above, but they never touch. This is a ray. One endpoint, one arrow tip. Moving on. These are considered angles. Okay, so let me clear up that a little bit. Angles. This is an acute angle. An acute angle is between less than 90 degrees. This is a right angle. Okay, so this is acute. This is right. I'm just going to put RT. It has 90-degree angle, exactly 90 degrees. This is considered obtuse. Obtuse angles are greater than 90, but less than 180 degrees. And this is considered a straight angle, and a straight angle is exactly 180 degrees. Okay, now remember, you can always fast forward if you don't know, or you don't remember, you don't understand it. This is a triangle. These are all triangles. These are identifying triangles by their sides. This has no sides the same. See how there's one little tick mark here, two here, and three here? That means this side is not equal to this side or this side, so this is considered scalene. This has one tick on each side. That means they are all the same. That means this is equilateral. Okay? This has two sides that are the same. This is known as isosceles. Okay? An isosceles, an equilateral, or a scalene. These triangles are identified by their angles. This is considered the right triangle because it has a right angle. And remember, a right angle is 90 degrees. These three angles are small, like they are acute angles. They are all less than 90. So this is considered an acute triangle, where this has an obtuse angle. Now remember, a triangle can only have one obtuse angle, but that's all you need to call it an obtuse triangle. Now, moving on. Now remember, this is just a fast-paced version of everything. The polygons, okay? The smallest polygon has three sides. You cannot connect less than three. So for instance, see, two sides cannot make a polygon. But once I connect it, I have made the three-sided polygon, which is called a triangle. The four-sided polygon is considered quadrilateral. Now, there's a lot of four-sided polygons, but the name of it is the quadrilateral family. There is the rhombus, the rectangle, the parallelogram, the trapezoid, and the square. But if somebody asks you what is the name of the four-sided polygon, you should call it a quadrilateral. If they ask you a four-sided shape, you need to get specific. Five-sided polygon is a pentagon. Six sides is a hexagon. Seven sides is a heptagon. They also have a name called a septagon. 8 is an octagon, just like the stop sign. 9 is a nonagon. 10 is a decagon. I'm going to pause. These are the four-sided quadrilateral family. The polygons is the quadrilateral family. This is what a parallelogram looks like. Opposite sides are equal. Looks a lot like a rectangle, except the corners are not 90 degrees. The rectangle has 90-degree corners. All of the quadrilateral families have 360 degrees in each of them, 360 degrees in some way. The square has all sides are the same. Each of the corners are 90, 90, 90, 90, and 90. Make your 360. A trapezoid has one pair of parallel sides, whereas all the rest of the quadrilateral families have two pair of parallel sides. That pair, this pair. The rhombus is a lot like a square. It has four equal sides. However, the angles are not 90 degrees. There are two acute angles that are the same measure and two obtuse angles that are the same. Looking at this, obtuse angle is the bigger one. The acute angle is the smaller one. These two are acute. Those two are obtuse. All right, moving down. Perimeter is a very easy piece. Perimeter is nothing more than add up the sides you see. So in this one, if they ask you for the perimeter of the shape, you just add up all the sides. It's like, think of a fence going around the outside of your yard. This would be 8 plus 8 plus 5 plus 5. The perimeter would be 26 units. Now, if it had this is not units, sorry, this is inches. I gave a measurement there. This little weird shape, it has 1, 2, 3, 4, 5, 6 sides. That is a hexagon. Even though it looks very strange, you would add up all the sides. You'd add the 8 plus the 7 plus the 4 plus the 5 plus the 6 and plus the 9 to get a total of 39 centimeters, because I gave you a label. Now, looking at the area. Areas have their own formulas. Okay, so the first one is a parallelogram. Okay, area of a parallelogram of some kind. All you need to know is B stands for base, H stands for height. Base is what lies flat, height sticks straight up. Think about going to the doctor's office. When you go and get your height done, you are standing straight up. This is base times height. So the base is 12, the height is 5, and 12 times 5 is 60. Big A means little 2. That means we have to put a little 2 power on it. 12 times 5 is 60. Base times height. Base, height. Height is not this 7. The 7 is slanted. We do not go to the doctor's office and stand like at an angle. We stand straight up and down. So this base happens to be 4. This height happens to be 9. We multiply 9 times 4, we get 36. We put inches, little 2, because we have a big A. The triangle is half of the base times height formula, because if we look at this shape and we cut this shape in half, we have formed a triangle. That is why it's half of that formula. Okay, so we do base times height, cut the whole answer in half. We know that half of the base, or this times this, cut it in half, means the same thing. So we can put our base in, 6 times 12, and we do a half of that. So we could do half of 6, which is 3. 3 times 12 is 36 millimeters, little 2, because we have a big A. Or we can go 6 times 12, get 72, and then take half of it, which is 36 either way. Half base height. 4 times 2.5, and then cut it in half. So our base is 4. Our height is 2.5. You can do 2.5 as a fraction or turn it into a decimal. And then we have to take half of that. So we do 4 times 2.5. We're going to get 10. And then half of 10 is 5 feet squared. Big A, little 2. Okay, I'm going to pause it. All right, now we're talking volume. Volume is length times width times height. A lot of kids learn this in science class. Then sometimes they give you this big B. This big B is length times width, because if you can think of this, the base is length times width in order to create that bottom of that shape. So we simply go big V equals LWH, volume equals 12 times 6 times 8. And we do the math. 12 multiplied by 6, which gives you 72. And then we times that by 8 again to make our final answer is 576. Now notice I didn't have a label here. This is where we do a unit. But see how we have a big V? We need a little 3. Big V, little 3. Big A, little 2. Okay, that's volume. Okay, so now we have area of an area and working backwards. So area, we know that our area formula is length multiplied by width. They give us the area of the backyard. So they gave us our area. So in place of that big A, we are putting the number. See, they gave us the area. This is what happens when we do things and we have to work backwards. We are given the answer. We are given one piece of this. This is the length is 9 feet. This is a really bad looking FT. So in place of the length, I'm putting a 9. We do not know the width. We have to work backwards. We just learned how to do this. This is a one-step equation. I see multiplication. I have to do its opposite. So I have to divide by 9. If your teacher does not use this division bar, fraction bar as division, you could use old school division. We take 48.6 and we divide it by 9 on the side of our paper, and we will get the width equaling 5 4/10 feet. Now be careful, this answer is not the squared part. We already had the squared part, which was the big A little 2. So all we need is the piece. Okay, that is working backwards. If you missed that, rewind this. Hold, I'm pausing. All right, so now we're doing a thing called constructing a net. Sorry for the whiteout at the top. I was not redoing this whole page. Rectangular prism and a cube. If we have to construct a net drawing of either of these things. Okay, so a rectangular prism, when drawn naturally, looks similar to that. Okay, that looks a lot like a cube, but I could make more of a rectangular prism by making longer sections. Okay, so we're going to call that our cube, then call this our rectangular prism. Okay, so if I have to take this and make it into a net, it has a front, a back, a top, a bottom, a left side, and a right side. So there's 6 sides to these things. So if you're drawing a cube, you just want to try to keep everything roughly that same distance. Anytime they ask you to make a cube, look for something that looks like a T. Now, they can give you some weird ones, though. They can make it look like this, and then they can put one here, and then one way over here. This is still a cube. There's still 4 running down the center, and 1 on each side of the wing. Just, you have to visualize there. So there's a lot of versions of a cube. But if you were asked to draw a net of a cube, it kind of looks like a lowercase t with a bunch of squares. There's 6. Remember, this could be the top, but the next piece wouldn't be the bottom. This would be the bottom, because a top and a bottom don't touch. There's a wing or a back or a front. So this could be your front. This could be the back, like the BA, and this is just a left and a right. So that's kind of how you make a cube, okay? So you can rewatch that if you need that. I had to erase that space. Rectangular prisms, usually we have one that's certain size, maybe one's a little skinnier, then you have that same size again, then we have the one that's a little bit skinnier, and then our boxes could go wherever. If you're going on a bigger rectangle, go on the bigger rectangle. If you happen to put it on the skinnier of the rectangles, then just make sure that you skip every other one to do that. Okay, so that's how you construct a net if you are asked. A square or rectangular pyramid. These I struggle with a little bit, but you put the box on the bottom or you put the rectangle on the bottom. And you just start with a point, and then you just connect up through and drop a height down and connect it. Okay, so you can kind of do this, and then you kind of like go up to the top to give it that three-dimensional appearance, and that's what you kind of have to do. Okay, so that's my versions of nets if you are asked to draw any of those. Surface area on a grid. Now, surface area is not regular area. It's how much it takes up. So if you could figure, if you visualize this, these wings standing up, this right here is a pyramid, okay? So surface area of a pyramid. What you have to do is you notice there's 4 triangles and 1 rectangle. You got to find the area of each of these pieces and then add them all up. Now, key thing is here, this triangle is the same as this triangle, and this top one is the same as the bottom. So when you get the answer to 1, you just can plop it in. So the first thing I'm going to do is I notice that this is 1, 2, 3, 4, 5 across and 2 up. So that means a 5 by 2. So my rectangle is 10. Okay, that's the middle. That's 10. So this is a 5 by 1, 2, 3, 4. So I have a 5 by 4 triangle. The formula for an area of a triangle from the other page is half base height. So I have a 5 times 4 cut in half. 5 times 4 is 20. 20 cut in half is 10. So this triangle up here is also 10. So is this. This triangle on the side is 1, 2, 3, 4 by 2. So 4 times 2 cut in half. 4 times 2 is 8. 8 cut in half is 4. So this is a 4 and this is a 4. And then I add them all up. So I have 10, 20, 34, 35, 36, 37, 38. This is 38 units squared. This is surface area. It's got area, big A, little 2. This one has a couple of ways. You can find this one and you got another one there. Find this one, you got another one there. Find that, you got another one here. Or if you can't remember how to do this, you can count all those boxes because surface area is the inside area. But I don't think I like that. So I'm going to find this. This is a 2 by 1, 2, 3, 4. This is just length times width, base times height, however you want to call it. A 2 by 4, 2 times 4 is 8. Got another one there. This is 1, 2, 3, 4, 5, 6, 7. 7 by 2. 7 times 2 is 14. This is also 14 in that part. This is a 1, 2, 3, 4, 5, 6, 7 by 1, 2, 3, 4. 7 times 4 is 28. 28. And then all we have to do is add 8 plus 8 plus 14 plus 14 plus 28 plus 28. Our surface area here is 100 units squared. That is the surface area of that shape. All right, looking at surface area when it looks like this. Surface area has its own formula. Not going to teach you the formula right now. I'm going to teach you a faster method to the formula. So you look to see who can play. So the 12 can play with the 6. The 12 can play with the 7. The 7 can play with the 6. That's all that can play together. So when we have a 12 by 6 bottom, we also have, see that bottom? We also have that same shape on top. So I need 2 of each of these. When I have the 6 by 7, that's that side. That's also that side. Okay? And same with this. So we're going to do the 12 times 6, which is, we have our 12 times 6, which is 72. And then you can multiply that by 2. And then we have our 12 by 7, which is 84. And our 7 times 6, which is 42. I'm going to add up all of these sides. Now, mind you, this is only 3 sides. So I'm going to go 72 plus 84 plus 42. I'm going to get 198. And now I need 2 of them. Because when there is a bottom, there's also a top. And when there's this front, there's a back. When there's a side, there's another side. So I need 2 of all of this. So I'm going to take 198 and I'm going to multiply it by 2 for 396 inches squared. Big A, little 2, give it a label. I'm going to pause, switch my paper. Okay, so now we're going to find the area of an irregular shape that we are going to build a box around it. Now, we don't have a base and a height of this style triangle, so I'm going to go from the vertex angles and I'm going to make a box around this. Now, when I make a box around this, I have to be very careful because the concept is I need to pop out this little scrawny triangle that goes all the way up here, all the way down and over, this triangle right here, and then this one up here. Okay, so first thing I'm going to do is I'm going to find the area of this box. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 on that bottom, and 1, 2, 3, 4, 5, 6, 7, 8. So the rectangle, the big rectangle around it, the rectangle is 10 by 8, so the rectangle is worth 80. Okay, 80 units squared, base times height. I'm going to be taking all those triangles away from it. So I have to find the area of this scrawny little outside triangle. So I have a base of 1 times 1, 2, 3, 4, 5, 6, 7, 8. So this triangle that I'm coloring right here, this triangle, it doesn't look like a triangle right now, but it is. Okay, so if we look at that again, if we go from this here over and then back up to there, that's the triangle we're talking about. This is a 1 by 8. So remember, formula for triangle is half base height. So this is base of 1, height of 8, cut it in half. 8 times 1 is 8, cut in half is 4. So this triangle right here is worth 4. I'm going to be popping that out after. What I mean by that is I'm taking it away. It's like a little kid using scissors to cut out this triangle. So this is a 1, 2, 3, 4 by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 4 times, so 10 times 4 in this formula. 10 times 4 cut in half, that's 40. Half of that is 20. This triangle up here is worth 20. This is a 1, 2, 3, 4 by 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is a 4 by 9. So this base of 9, 4. 9 times 4 is 36. Half of 36 is 18. So now I have to take 20, 18, and 4, get a total, 8, 9, 10, 11, 12, 2, 3, 4. I have to take away 42 units, okay? If I take away 42 units from that, I'm going to get 38 units squared is that triangle in there. So by subtracting out all of these triangles from the big rectangle, I have formed the area of that weird shape, okay? Now we're moving down to here. Okay, so we're looking at this one over here, this area. So we are missing this long side and we're missing this bottom right here. So in order to find the full long side, if we look at this part right here and we move this over from here to here of this long side is worth 14. This 8 I can move directly over here and that's worth 8. So this long side right here is worth 22 if I need it. Okay, see how this is 5? We can find this bottom out by taking the total, which right here, 12. If I take away this 5 from the 12, that's going to give me what's left, which is 7, because 7 plus this 5 makes 12. That's if we need perimeter. If we needed perimeter, we would need this plus this whole side plus this plus this plus this plus this. I'm just checking for area. So now I get to cut this shape. Okay, I'm going to get rid of this. I'm going to put 22 just in case. I'm going to keep that 7 down here. You can cut this shape like this, or you can cut this shape like this. That is up to you. because you were either going to have a 22 by 7 this way and an 8 by 5, okay? Or you cut it this way and you're going to use your 12 by 8 here and your 7 by 14 here. Whichever way you do it, you're going to get the same answer. So if I did it this way, the 12 times the 8, that part would be 96. And if I did the 14 times 7, that would be 98. 14, 194 units squared. Okay. If we did it the other way and cut it the other way, cut it the 22 by 7, 8 times 5 was 40. 22 times 7 is 154. And if I added 154 plus 40, I still get 194. So either way, it's the same answer. Okay? Now, net drawings. This is kind of a cool thing. So if I had to match my net, okay, matching the net. This one comes to a point. So this is a pyramid. See how these have rectangle faces? Maybe even a square base? This is considered a prism. That is a prism. A prism doesn't come to a point. It doesn't have rectangle faces. Rectangle faces are prisms. Triangular faces are pyramid. This is this. This is this. This is this. Okay? So that's how you work that. Area of a trapezoid. So this is a trapezoid. We don't teach the trapezoid formula currently. So what we do is we decompose a trapezoid into a rectangle and two identical triangles. So we know that the triangle formula is base times height divided by 2. So if this center section right here is 12, this means this wing is 3. If this height is 8, this height is 8. So we have a 12 by 8 rectangle. So the rectangle is 12 times 8. And the triangles are base times height divided by 2, or half base height. 3 times 8 is 24. Half of 24 is 12. So we get 96 for the rectangle, 12 for that triangle, 12 for the other triangle. We add it all up. We get the area of a trapezoid. 6, 7, 8, 9, 10. 9, 10, 11, 12. 120 feet squared. So if you need to look at that again, we have two triangles, one rectangle. Take the rectangle, find the triangle. We have two of the same triangle. Put it there, add it together. Area of a trapezoid. Okay? Perimeter and area of an irregular shape. Okay, we're going to start with this one over here. Perimeter, you literally have to just be careful and count how many. So we go 1, 2, 3, 4, 5, 6, 7, 8. We write it down. We know that this side's also 8. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. And we have 9. Perimeter is adding up all the parts. 9 plus 9 plus 8 plus 8. So if we got to add them up, 9 plus 9, 8 plus 8, and we're going to get an answer of 34 units. There is no squared on this. This is a P, perimeter. Area has a little 2. Area is length times width or base times height. 9 times 8. So we have 9 times 8, which is 72 units squared. That's for that one. Now we're going to an irregular shape. I'm just going to get rid of this so we don't have anything else you're looking at. If you need to rewind that, you go for it. Irregular shape means I have to decompose this. So I look at this. You can either cut it here like this, find this rectangle and this one, or you can go like this and find this big one and that one. This is what I'm going to do. So I go, we have a 1, 2, 3, 4, 5. I need it for the perimeter. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. Don't need that right now. 1, 2, 3, 4, 5, 6, 7, 8, 9. I got all my sides. Now I add them up. 12 plus 3 plus 7 plus 9 plus 5 plus 12 again. So I have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I get my perimeter as 48 units. Now I have my sides. If I cut it here, I am using my 12 by 5. This 9 means nothing right now. I need this times this. 12 times 5 is 60. Then I don't need this 12 up here anymore because I need this part, 7 by 3, which is 21. I take my 60, my 21, add them up together, get 81 units squared. 81 units squared. Okay, irregular shape right here. Last, certainly not least, of all of the geometry unit that we did in 30 minutes. This is a rectangle with a triangle. I would take this and put it right here. And then notice this is not a full triangle. There's another piece of a rectangle right there. We have a little baby rectangle. The triangle doesn't have a drop down. Okay, so I actually have, let me put another pen, as I dropped my pen. This is the triangle. That's a rectangle. And then I got the big rectangle. So I got a little decomposing to do here. So this little rectangle is 1, 2, 3, 4, 5 right there. 5 on the area. So 5 on the area. And we have 1, 2, 3, 4, 5 by 1, 2, 3, 4, 5. 5 times 5 is 25. 25 cut in half is 12 and a half, so that triangle is 12.5. And now I have this big one to find, which is a 1, 2, 3, 4, 5, 6, 7 by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So by 13, so 13 times 7 to get my big one, which is 91. So I have to go 91 plus 5 plus 12 and a half. So 12 and a half plus 91 plus 5, and that's 108 and 5/10 units squared. And I thought about this after. You wouldn't be asked at the middle school level to find perimeter of something that has a diagonal as of a triangle. If this were a shape like this, we could do that. But since we can't do a perimeter on this without knowing a thing called the distance formula. So my bad. I was going to teach it, but it's not your level. I hope this all helped. Anytime, rewind, fast forward. And as always, I love math. And Diet Coke, and CrossFit.